Okay, welcome to today's intercontinental Zoom event, Eyewitness Identification from a Different Angle. My name is John Wixted, and I'll be the moderator for this event today. I'm a professor at University of California, San Diego, where I study a variety of memory-related issues, such as signal detection models of recognition memory, the coding of recognition memory in single neurons of the human hippocampus, and eyewitness memory, especially eyewitness identification. For this event today, we've assembled a group of 11 expert panelists to discuss a novel eyewitness identification procedure known as the interactive lineup. If you watched the short online videos presenting recent research investigating that procedure, you know that it consistently and pretty substantially elevates the ROC, which is a plot of the hit rate, the probability of identifying a guilty suspect from a target present lineup versus the false alarm rate, the probability of misidentifying an innocent suspect from a target absent lineup. What that essentially means is that the interactive lineup can achieve both a higher hit rate, which is a good thing because you want to get the bad guy, and a lower false alarm rate, which is also a good thing because you don't want innocent suspects being misidentified, compared to various typical lineup procedures. So in that sense, the interactive lineup serves the cause of justice, or at least has the potential to do so, and that's basically what we're here to talk about today. In a few moments, I'll call on each of our 11 panelists to briefly introduce themselves, about a 1-minute self-introduction. Then I'll ask Professor Heather Flo to give a short presentation on the interactive lineup procedure, just to refresh your memory of exactly what it is and what it can do. And after that, I'll get down to the main business of posing questions to the expert panelists. And note to our panelists, these questions are really just invitations for you to share your thoughts. They're basically conversation starters. So feel free to completely deviate from the questions if you wish, and share other thoughts that might be on your mind today. All right, a few ground rules. This event will run for a maximum of 90 minutes. Everyone who isn't talking, please keep your microphones on mute. During the question and answer period, I'll call on panelists who have their virtual hand raised if they'd like to jump in as I'm questioning a different panelist. That's perfectly fine. If the audience has questions, go ahead and put them in, I suppose it's the question and answer box. And someone will eventually read your question and we'll try to answer it. Okay, well, turning now to the panelist self-introductions, I'll just call on people in the order in which they were listed on the website program. Professor Carolyn Semler, why don't we begin with you?
Thanks, John. It's really exciting to be here today. I'm a professor at the University of Adelaide in South Australia, so coming to you from very early morning in South Australia. Really excited today because I get to talk about eyewitness identification, and one of the things I'm really interested in is measurement models and the development of what I like to call the thermometer that measures memory strength. So I think about lineup tasks as if they were a device for measurement of memory strength. And I'm really excited to talk today about that and to hear about what's been going on in this new development of a procedure that seems to really tap into and allow witnesses to translate their memory strength into an identification decision.
Okay, thank you. I think Professor Laura Mikus was unable to join us today. She's the next one listed there. She's a longtime colleague of mine, so I'll be pinch hitting for her today. And the next person on my list there, Dr. Karen Amendola.
Thanks, John. My name is Karen Amendola, and I am the Chief Behavioral Scientist with the National Police Foundation in the United States. By training, I'm an industrial and organizational psychologist, but I am currently under a grant from the National Institute of Justice to conduct a multi-part study, including a national survey of current practices in the US.
Thank you. Dr. David White.
Hello, John. Thanks. And Heather, thank you for having me. I'm a cognitive psychologist at the University of New South Wales in Sydney. Again, an early start for me, as with Carolyn. I'm interested in individual differences in face perception broadly. And most of my work has actually been focused on face identification tasks that don't involve memory. And the main insight there is that the task of face identification is very difficult, even without memory demands. For example, where a CCTV is being compared to a mugshot. Thank you.
Okay, thanks. Professor William Wells.
Thanks, John. Hello, everyone. I am coming to you from Sam Houston State University, which is about 70 miles north of Houston, Texas in the United States. I am a professor of criminal justice and criminology at Sam Houston State. And my research is a little bit different than probably most everyone else on the call. I do applied work with police agencies around the United States, studying police responses to violent crime. And this involves studies of police investigation practices. And I've worked in the area of investigator use of forensic evidence, like DNA and ballistic evidence, and also the way they collect and utilize eyewitness identification evidence. And then a few years ago, led a study with the Houston Police Department that tested different methods of collecting eyewitness identification evidence. And really fortunate to have been able to connect with and work with several folks on the webinar today and publishing some results from that study. So I'm happy to be here. Thank you.
Okay, thanks. Dr. Anna Bobak, I hope I'm pronouncing that correctly.
Yeah, great. Great pronunciation of Polish. Hi, everyone. Thank you for inviting me. My name is Anna Bobak. I'm a Leverhulme Early Career Fellow at University of Stirling in Scotland. So late evening for us here. Well, early evening, I suppose. My main interest is in individual differences in face perception, but also decisional characteristics. So why some people are more prone to make certain types of decisions in face perception tasks. So I'm really excited to discuss this new procedure here. Thank you.
Okay, thanks. Next up, Wayne Collins.
Evening, everybody. I'm Wayne Collins. I'm the director of the National Viper Bureau, which is a police department in the UK. I'm responsible for managing the video identification parades that are produced by around 22 forces here in the UK. It's about half of the UK. I manage a range of staff and IT systems to allow that to take place, which includes running a volunteer database, managing the editing techniques and the training that's employed to deliver that service. Viper has been around in policing in the UK since 1995, but became more prominent in 2002 due to some changes in legislation. And we're looking to work more with academics. Indeed, our door was open to academics, fully opened a couple of years ago, and we're working with some actively right now, hoping to have some good research in the next period.
Thank you. Mick Gibbin.
Thanks, John. Hello to everyone. My name's Mick Gibbin. I'm a software developer based in the UK with over 30 years experience in the industry, and for my sins, I've spent the last 20 years focusing my efforts on the design and build of various bespoke identification software systems. I am currently head of research and development at ProMat, with my most recent projects focusing on video and still image identification parades, witness albums, facial recognition systems, chroma key green screen applications, and virtual reality systems. Thanks, John.
Thank you. Professor Alice O'Toole.
There we go. Hi, I'm Alice O'Toole. I'm a professor at the University of Texas at Dallas, and I've studied a lot of different aspects of face recognition over the years. In particular, relationship between human and machine perception. I've also looked at some just basic issues in how people remember and encode faces and how that matches or doesn't match with the way we think about the neuroscience of it and the way the brain does it. So I've been interested in that over the years. I am probably the only person on this panelist who has never done a single study in Eyewitness. So I am in some senses here as much to learn how the basic science gets translated. I mean, I certainly have followed the literature from a distance, and I find the interactive lineup really exciting. It makes use of some very clear principles from the basic perception that it's great to see get translated. It's excellent to see the signal detection models so well used now, and they have not always been. So lots of progress, lots of exciting times. And yeah, we've studied forensic, we've studied the ability of forensic professionals to do the task and compared it to machines and so on with colleagues, including David and some probably other people who are sitting out in the audience. But anyway, I'm really looking forward to hearing and learning here as well. So thank you.
Okay, thank you. Professor Tom Albright.
Yes, thanks, John. So I'm Tom Albright. I'm on the faculty of the Salk Institute for Biological Studies, which is a private nonprofit research institute in La Jolla, California, sitting on a bluff overlooking the Pacific Ocean. It's a spectacular place. It's mostly molecular biology. My background is in experimental psychology and neuroscience. And I'm also adjunct in John's department down the street from me here. I run a lab and have for many years that looks at the brain basis of visual perception, visual memory, and visually guided behavior. And at the sort of most basic level. And a number of years ago, I've thought about this problem for many years because I've studied the visual system, but a number of years ago, I was invited by the National Academy of Sciences to co-chair a committee that was to look at the validity of procedures for eyewitness identification. I co-chaired it with Jed Rakoff, who's a federal judge from New York. And that committee, which some of you may be familiar with, produced a report in 2014, which provides a number of important recommendations for reform and additional research. I went on from that and I served on the short-lived National Commission on Forensic Science, which took up a lot of similar issues. And I currently serve on the weirdly named NIST Organization for Scientific Area Committees for Forensic Science. I'm on the Human Factors Committee, which again addresses similar issues. And so I fell down this rabbit hole of eyewitness identification a number of years ago and haven't found my way out yet, but I'm happy to be here.
Okay, thanks. And next, Dr. Ryan Fitzgerald.
Thanks for the introduction, John. I am an assistant professor of psychology at Simon Fraser University. This is based in Vancouver, so I don't get to complain about the time zone I'm in. It's a very socially acceptable 10 a.m. in the morning here. My interests are primarily in eyewitness identification. And in my previous research, I've looked at things like the medium that's used to present lineup presentation, which is quite relevant today, looking at things like whether photos different from videos and whether those different from when people appear live in person. I've also got a program of research looking at how the fillers in the lineup, the people who are not suspected of the crime, how to select those for lineups. And I've also recently took an interest in policy, and I'm quite interested in variations in how lineup policies, how they vary across the world. So we recently did a review where we found as many policies as we could, and to our surprise, we found about 50 of them that were accessible to us. So that's been another focus of my research. Thanks.
Okay, thank you. I think I called on all of our panelists, but if I missed anybody, jump in right now and introduce yourself. Otherwise, we'll turn to a short presentation on interactive lineups provided by Professor Heather Flo. But first, I'll give a quick bio for her. She's a professor of forensic psychology at the University of Birmingham, where she conducts two main lines of research, one on sexual violence and the other on eyewitness identification. the latter of which is obviously our focus today. She received her PhD from UC San Diego in 2005 and has been a prolific and prominent researcher ever since, including recently completed service as an associate editor for the journal Applied Cognitive Psychology. A few years ago, just a few short years ago, I think, she moved from the University of Loughborough, I think it's how it's pronounced, University of Birmingham. And I think it was around that time that her work on interactive lineups, much of it conducted in collaboration with her colleague at Birmingham, Melissa Colliff, really began to take off. So let's hear a little bit about that.
Thanks so much, John. It's really great to see everybody here. It's an all-star panel, and it's a pleasure to be able to discuss and debate not only interactive lineups, but other prevalent and prominent issues in our fields of both eyewitness identification as well as forensic face matching, which is another important component of today. And we've trialed interactive procedures in both of those fields, and the results have been really interesting and really compelling. And I date this project back to my youngest daughter, who is now age 7. And one of her first field trips was to visit with ProMat, where she stayed out in the car park as I went inside and I spoke with Mick and colleagues about the promise of interactive lineups and got their feedback about what they thought, because we wanted to develop this system so that it could be useful in the context of UK police forces, as well as police forces worldwide. But we began with this idea that UK police forces have video libraries, which is brilliant for composing fair lineups because you have a lot of different people to choose from. Whereas with live lineups, as Ryan and colleagues will tell you, there's a real challenge in making sure that lineups are fair if you're going to use a live procedure, because often in many locations, you don't have suitable fillers, at least not readily on hand, and they're very expensive to organize. And in some places like South Africa, where they only use live procedures, it's rather dangerous because they have to transport people who are imprisoned quite a long distance to partake in lineups and witnesses as well. So it's expensive and dangerous even in some circumstances. On behalf of myself and Melissa Colliff and Harriet Smith, who are my co-hosts today, we were really pleased to welcome everybody. We want to thank you for your time. I'd also would like to thank the people who gave on-demand talks to share the research. Thank you for taking the time to do that, as well as the Festival of Social Sciences organizers at the University of Birmingham, who have been completely instrumental in enabling this event to take place. Thank you so much. I thought a good way to start today would be to test your phenomenology. So here we go. Okay, now a very brief retention interval. Which one is he? The numbering goes from starting at the top row on the left, that's 1. The next one over at the top row is 2nd, 3rd, and so forth. So the bottom left-hand corner is number 4 and so on. So I'm going to put up a poll. We'll see how you do. Right, that looks like just about everyone. And we've got a mixture between not there and number 2. Right, okay, that's interesting. So the correct answer was not there. And to be fair, I did mislead you a bit. I suggested that there was someone present to be picked. I didn't give you a standard warning that is encouraged in all jurisdictions throughout the world, that the perpetrator may or may not be present. And so I biased people to choose. So that was very naughty of me. So can you still see the poll? It still appears on my screen. How do I get rid of it? Can you all still see the poll? Is it on your screen or just on mine?
Just on yours.
Just on mine. Okay, that's fine. I could deal with that. So here's an example of a live lineup. And as Ryan and his colleagues, Heather Price and others who have looked around the world to see what kinds of procedures are currently run, there are still places that run live lineups. But as I mentioned in the beginning, it's very difficult to run a live lineup procedure. And so people have switched to modalities that are largely photographic or that are also video-based, like here in the UK, we use video lineups. And the presentation either can be a simultaneous presentation where you get all of the images in front of you at once. Depending on jurisdiction, that number can vary, but it's predominantly 6, and that sometimes it's called a 6-pack if the images are displayed together simultaneously. In other places, even some jurisdictions in the US, sequential procedures are used where each image gets displayed one at a time. The stop rules can vary across different countries. Some countries or some jurisdictions have it such that you either see all of the photos before you make a decision. Indeed, in some places like the UK, you have to see them twice, and then you can make an identification decision. While in other places, you make a one at a time judgment. Once you say yes, you make a positive ID that someone is the perpetrator from the crime, the procedure terminates. And even if there are still images yet to be seen, you don't see them anymore. And that is something that psychologists have studied, like Ruth Horry. John has also done research looking at how the stop rule can influence people's decision process. Another, I can't see what is on my screen. There we go. So another way in which lineups can be conducted is by using a video procedure. And the way that this happens in the UK is that you, I'm going to stop the share and get rid of my poll, share the results, stop sharing. And make that go away. Okay, good. That was irritating. I can't get rid of this poll.
Let me have a go on my end.
So with the video procedure, what is really interesting about this is that it's dynamic. It allows the eyewitness to have a complete view of the face. It always starts with the lineup member facing forward. They turn to the left, or and then they turn to the right. And then the witness will see multiple clips. If you're in the UK, you'll see 9 or more of these video clips. Embedded among them is the police suspect, and everybody else is known to be innocent. In the UK, those individuals are called volunteers, but in other jurisdictions, those known innocents would be called fillers or foils. There have been a number of research studies comparing mediums of presentation to try to understand whether people's ability to discriminate guilty from innocent suspects is better depending on the procedure that's used. And most of those studies find a few comparisons where false identifications are lower, for instance, in a video lineup procedure compared to a photographic lineup procedure. But by and large, when you look across the whole literature, you find that there's no difference between photo and video. And recently, Ryan and colleagues have looked at this within the context of live lineups as well, comparing them to video and photo, and have found no compelling differences across those modalities, which is really interesting. And perhaps one reason is that many studies don't carefully control the presentation of the to be remembered person. So you'll note that the perpetrator that we saw very deliberately looked around so that our participant witnesses could see his face from all aspects and encode the face from all aspects. So then if there are differences that arise because a witness at test can match the viewpoint from which they studied the perpetrator, and that boosts performance, then we'll be able to detect that because it's clear that our participants had the opportunity to see the face from all viewpoints. This is an example of our simultaneous independent movement interactive lineup, where participants can grab with their mouse and rotate any of these faces into any viewpoint desired. The program is recording what they're doing moment by moment, so we could tell from what perspective they're looking at the face, how they're moving the face, and able to then profile accurate witnesses compared to inaccurate ones to try to get some hunches about what might benefit performance. Another example is the simultaneous joint movement lineup, where all of the faces rotate in the same way. And according to the diagnostic feature detection theory put forward by Laura Mickes and John Wixted, we would predict from that that performance would be superior, so to speak, in a simultaneous joint movement lineup, because people's ability to discriminate is better because they could rule out certain features, like looking at the face from the side. It's not very informative to look at the, for instance, the hair color, but maybe the ears are quite diagnostic because they vary across all of the lineup members, and that could be used. So in brief, you get more diagnostic features when you have an interactive lineup in the ability to see the face from different vantage points, when you're able to see the face move, when you're able to see how those features then, how they look when they rotate. Sometimes this is called 2.5D, because you do have sort of a pseudo 3D mental representation, some would say, because of the ability to see these faces move. Just one more thing before I turn it over to the panelists. You might also hear tonight people talk about target present versus target absent lineups. And just so we're on the same page, a target present lineup is one in which there's a guilty perpetrator present. And the correct answer for this type of lineup is to identify the guilty suspect. Identifying a filler or a foil or a volunteer, all the same thing, known innocence, would be a false alarm. And to reject the lineup by not picking anyone would be an incorrect rejection. So it's another way to go wrong with the target present lineup is to not pick anybody. In a target absent lineup, we either have a blank lineup with all fillers in it, or the police have arrested an innocent suspect and embedded that innocent suspect among the fillers. And in this instance, if the witness were to identify the innocent suspect, that's the most egregious error because that individual can be charged. Whereas if they identify a filler, that's not great because the witness has now discredited themselves. But at least in that instance, it's a known innocent. And rejecting the lineup is the only correct response in this particular type, because you shouldn't be picking anybody because there's nobody there to be picked. There's no guilty perpetrator. So that's all from me. It was just a whistle-stop tour of the different lineup procedures that are out there. There's much more to be said, so I look forward to the discussion.
Okay, thanks for that presentation, Heather. And so now I'll move on to questions for panelists. And while thinking of that, it occurred to me that the main focus today will probably have to do with the potential use of the interactive lineup in the real world, the application of this new technology. I just thought that maybe there would be a magnetic attraction to questions about that. So I divided the questions into basic science questions about, how does it work exactly, versus the applied questions. And I thought I'd start with the basic science questions just to make sure we cover some of that. And also I thought that maybe the answers to those questions would inform, its potential utility in the real world. So that's why I did that. I don't know if it was the right way to do it, but that was the logic behind it anyway. So I'll now start calling on individual panelists and throwing out questions to them, which again, I invite them to ignore the question if they wish. And discuss what's on their mind for a few minutes, and panelists can raise their hand. Okay, I'll start with Tom Albright. You might not know Tom Albright is a member of the National Academy of Sciences, and probably more than anyone here is involved in both the basic science of eyewitness identification and translating that into the real world. So for him, I have a question in both halves of this discussion, but I'll start with a more basic science question to see if any thoughts about that. And my question was, do you see any promise in combining the interactive procedure that we just heard about with a paired comparison procedure that you recently introduced in, I think it was a Nature Communications paper, and maybe a brief description of the rationale of paired comparisons? You could give us that if you wish, but Tom.
Well, thanks, John. The simple answer to your question is, of course. There's no reason why you couldn't pair this with the method that we published last year in Nature Communications. So for those of you who are not familiar with this, this is basically, we developed a type of lineup that draws upon a procedure that was first published almost exactly 100 years ago by Louis Thurstone. And it's the method of perceptual scaling by paired comparisons. And the simple idea, just to give you an intuition for it, is if you go to the optometrist will show you two lenses at a time, and he'll say, or she'll say, which lens is clearer, number 1 or number 2. And you do a series of lenses like that, you have no idea what's actually being tested. You're just asked to say which is clearer. And the optometrist, of course, is trying to determine the degree of refractive error from that. And the lenses, based on the responses to those paired comparisons, can be scaled according to the degree to which they resolve your refractive error. And so that's essentially what we did with the lineup. We took 6 faces. I suppose it doesn't really matter how many faces you are, although the number of paired comparisons increases dramatically with the number of faces in the set. But we did 6, and there are 15 possible pairs of 6 faces. And we presented them to subjects, and on each trial, the subject simply had to say which of the 2 faces was more similar to the person that they recall from the crime scene. And from those responses, and we did 3 iterations of each pair, because another thing you want to get out of this is a sense of how variable people are. And so that just gives you a measure of noise. And from that, and we pulled all the data from, I don't know, it's like 70 subjects in this. We pulled all the data and found very nice, we could calculate the ROC quite easily from this, and found that there is a very strong ability to identify the correct subject, not in a conscious directed sense, which is part of the problem with this method, or part of the reason why people struggle with this idea. But we got scaled representations of what we believe to be the strength of memory in their brains for each one of the faces that's presented. So I wish I had a figure I could show you, but in the paper that John referred to, there's a graph that illustrates the median strength of response to each face, and then some measure of error. And then you can simply take those data and apply a method, a statistical method that's entirely objective to determine the degree to which any one of those faces differs significantly in terms of the recognition strength from all the others. And that it works out beautifully. It's a very simple procedure. And to get back to John's question, now that I've gone over what the technique is, the answer is, of course, you could use these methods, these 3D interactive methods. You would simply present 2 faces at a time and sort of flip them around as you need in order to solve the recognition problem. Now, I want to make a more general point, which is that the question of whether to use these interactive methods with additional cues, this seems to me like a no-brainer. I mean, it's quite obviously going to benefit performance. And so the real question is not whether it's good, but why we're not using it. And I come at this from I'm trained as a biologist, and I come at this in part from an evolutionary perspective. So we humans evolved in an environment that has 3 dimensions in it, and that environment is replete with cues for the dimensionality of things, and that's essential for the things that we do in that environment. Which we could categorize into 2 major things: navigating through the environment or recognizing stuff that's important to us. And so we depend upon all those cues in normal vision all the time. And there is, in fact, if you go to the basic science literature on this, there's a huge literature on how visual cues support object recognition. And the general thrust of this literature is that we generally combine multiple cues in order to increase the probability of correct object recognition. And so it seems completely obvious to me. Just to give you an example, when I go to find my car in the parking lot, I use the standard 2-dimensional cues like the brightness of my car and the chrominance of my car and the sort of outline of it. But I also use binocular disparity cues for the distances of different parts of the car relative to me, which gives me an impression of the three-dimensional shape. I use relative motion cues. I move back and forth, and that's effectively what you're doing with these rotating objects, is you're using motion parallax to get 3 dimensions out of this. I use all these cues. We do this all the time in the natural world, and it doesn't surprise me in the least bit that this would benefit object recognition in this particular application. And so again, I come back to this question, not whether this is a good idea, but why are we not doing this? And I would guess, and some of you are closer to that end of things than I am, but I would guess that a lot of this has to do with just the practicality of it. You need to collect these, you need to make these 3-dimensional faces, and you want to have a large, this is another general problem, you want to have a large database of faces that you can draw from to include as fillers, and then you need to make a 3-dimensional model of the suspect's face. But all this is doable, and it's now far easier to do with powerful computers than it used to be. And it's just a matter of getting the people on the ground who do this to actually take it upon themselves. So that's my long answer to your question, John.
Okay, that was a great answer. I think I could see Heather Flo doing a little song and dance over there, hearing you say it's like obvious we should use this in the real world.
Yeah, and there's this, I mean, I think that this community, this applied science community, which is really important because it's such an important problem, should refer to this basic science literature on this. It's a huge literature on the role of visual cues and object recognition and the combining of those cues to improve.
You're the second neuroscientist that I've talked to about this, and the other one had like the exact same reaction that you're having, and he even sent me a chapter of owls and auditory perception at night, how like they can't move their eyes very well, so they orient to optimize the information gain, and like tons of I read a whole review of that and remind me that basically what you're doing in this interactive lineup is similarly, orienting to maximize the memory match signal.
You probably learned that owls have offset ears, so one ear is slightly higher than the other because there's this problem of not being able to identify things along the line through the middle of your head.
Yeah.
But anyway, yes, it's exactly the same kind of problem, but using the auditory system.
Yeah. So, and just one quick thing I want to add before moving on is, I see I have a hand up, Tia.
Yeah, we just have a question in the chat, but I'm happy to, if you want to finish what you were saying, John, I'm happy to read out afterwards.
Okay, we'll get back to that in just one second. I just wanted to say that a really intriguing issue, general issue that's out there is, what do you want to do with new procedures? Do you want to maximize discriminability? And I'm always saying, yeah, that's exactly what you want to do. You want to raise the hit rate and lower the false alarm rate. That's the goal. But another perspective that's been talked about a lot is, but that leaves information on the table. They have other memories of the fillers and things like that, and it just leaves a lot of information on the table. And maybe what the other thing you might want to do is maximize information. And the paired comparison procedure is one way to do. You get everything. You don't just get their pick. You get the structure of their memories of everybody in the lineup. And I think and enhancing discriminability by using interactive lineups, it does both. It adds information and raises the ROC, maximizing discriminability, but it can also be, there are also ways to maximize information. And I think I'm just going to throw this idea out there. It seems increasingly clear to me that going forward, the best, what we're going to want to do is stick with what we do now, a normal lineup, maybe with the interactive procedure added to it to maximize discriminability. Do that, step one. And step two, extract all the other information that's in that witness's brain. So you're also maximizing information. I think doing both rather than one replacing the other, both might be possible going forward. And there might be an argument to be made for doing it that way. The identification procedure is closer to the way they already do it. It is not asking law enforcement to make such a dramatic change, but you're also, after they get that information, you maximize the information one way or another, such as the paired comparison procedure. All right, that's just a thought I had.
And I want to complement that by also pointing out that one advantage to the pair comparison procedure is that the decision in the end is not made by the witness. And that's an important thing. We're extracting information from the witness's brain, and then independently somebody else is using an objective statistical procedure is making the decision. And that has the obvious benefit of overcoming biases that the witness might bring to the table.
Yeah, I can imagine that being sort of a step function where, you know, for a while, it's still what they said on the first test, and they use that in court, and like police investigators maximize the information from the second test and have to conduct a better investigation. And then it's gonna take a while for the legal system to get used to what you just said. But I can see it stage-wise, you know, I mean, one step at a time.
Yeah, I mean, the obvious response from the defense attorney is that, well, he didn't actually identify anybody.
Yeah.
But this is a communication problem between the science and the real world, where people are actually trying to prosecute these cases. But we have to get past that somehow.
Okay, so maybe now we'll turn to the question that came up in the
Yeah.
chat.
So the question is, what would you say are the main factors that influence the accuracy of eyewitnesses' memory recall during a lineup?
Well, so I'll try my hand at that question for starters, but there's so many. I mean, how you do the test is one thing. You know, what happened during the event is estimator variables and system variables, you know, so like factors that affect it during the test is say an unfair lineup. For example, if you conduct an unfair lineup, you know, people are going to be picking an innocent suspect with high confidence. That's nothing good comes from that. So that's a system variable that affects eyewitness performance during a lineup. But also, you know, if it was dark outside and they didn't get a good look at the suspect, they're not going to be able to identify him from a lineup. That will basically, in a nutshell, what that does is it doesn't really cause you to misidentify some random innocent person with high confidence because you didn't form a good memory of the suspect, of the perpetrator, I mean, at the time of the crime. It basically means that you're just not going to be able to make an ID, and odds are your confidence is going to be low because no one is going to strongly match the weak memory that you have of that perpetrator, and you're going to sort of be aware of that fact. And I don't know, that would be my answer to that question. So, okay, maybe I'll move on to my next basic science question, and I'll put this one to Alice O'Toole, and there's a couple in there, and I'll just read what we have, and then Alice, you take it from there. So I wondered if it might be the case that some facial features are more angle of view dependent than other facial features. And are there others that might be more viewpoint invariant, such as distinctive features like a tattoo or something? I don't know. And then separately, an interesting question was asked. Would it be useful to ask eyewitnesses about which viewpoint of the perpetrator they think they saw prior to showing them the lineup, and then begin the interactive lineup in one of those views? And then there's even more here that I didn't see earlier. Should we start to think about lineups as one part of eyewitness evidence that gets combined, sometimes across different people examining the same lineup, and maybe between experts comparing crime video to a lineup? Okay, I'm thinking about the wisdom of crowds and face identifications. So that's a lot. Maybe...
So actually, I added some of the other stuff because the answer to question one is yes. That's all the answer. Yes, there's definitely facial features that are more discriminable from different angles that will provide. And especially if someone has a distinctive feature that you can see only from a particular viewpoint, I think that's the beauty of the interactive procedure. You can put it, you can move the viewpoint to something that's going to better match your memory. So that's an easy one to answer. There's just decades of research showing that people just do. The closer you can match the experience of learning to the experience of test, and that would mean viewpoint, illumination, more generally, expression, the more accurate the person will be at least when they don't know the person. So that's kind of pretty straightforward, just I think why that works. So, you know, I don't know if people have a sense of what view they've seen, or if they, and I think actually I was really intrigued by the results that motion, which is part of what we see and experience in the real world, motion was not equally effective to giving the witness control of what they look at. We did some experiments many years ago, and we found exactly the same. Motion doesn't really help over static images or multiple static images that an experimenter kind of forces on someone. We kind of hypothesized that one of the problems with the motion is it presents a divided attention task. So when you see something in motion, you're processing both the person's identity and what you think they're doing. Like, looking around is like, you know, casing the joint, so to speak, or trying to, so your brain is doing two things. It's trying to come up with the intent of why the movement is being made, plus that distracts you from processing the identity. So when I first read these results, I was like, oh, okay, you know, motion should, technically speaking, if you cover the same angles and keep going back and forth, should be as good as interactive lineups, which clearly it's not. And so I, you know, maybe beg to differ a little bit. Too much information here can be bad. You know, information is information. Some of it's relevant to saying who the person is, and some of it's relevant to what they did, but they're different kinds of information, and they can, since they're overlapped in a single face, they can confuse you. And so I know that looks like a lot of stuff, and I will get, so other panelists get a chance to talk. I'm going to hold the wisdom of the crowd stuff, but I think that's something that's coming. We have to talk about the fact that you have 5 witnesses, go in, 3 find this guy, 2 find that guy. But anyway, I was just fascinated by the difference between the motion and giving the person control. And that was my best hypothesis at the moment.
Yeah, and you made me think of something, like if people do have insight into the viewpoint that they saw, I wonder, I mean, a great experiment that may have already been performed, but would be to basically compare presenting the photos in that viewpoint versus interactive lineup. I mean, it's conceivable that, you know, just presenting it in the viewpoint that they remember will elevate the ROC, that's, you know, the interactive lineup is letting them do what perhaps one could do in advance. I don't know if that experiment's been conducted, but that would be a great experiment. That would really be interesting to see what kind of insight people have.
And certainly if it can be established what viewpoint the witness saw from, then adding the other viewpoints confuse, or do they help? You know, like if a person is kind of standing on a stair above and watches something take place, you know, at the bottom of the subway platform or whatever, you know what pitch they're seeing things from, you know what angle they're seeing things from, and adding lots more information. I mean, it's an open question. Does that help? Does it hurt? Telling them something they didn't know about how the person looks from 3 other angles. Anyway, just things to think about. I think this is exciting, not only because it helps move the applied ball forward, but it opens up some ways of asking new basic science questions.
Yeah, I agree. Tia.
Yeah, so we have some more questions in the chat. So the first one, for the paired comparison procedure, I think this is referring to what Tom was talking about before. What do you think about comparing more than 2 faces at a time? So instead of comparing 2 faces, what about comparing 3 faces, 4 faces, 5 faces at the same time? And what kind of effect would that have on performance?
Well, we haven't done that. I mean, it's an interesting question. One of the advantages of the paired comparison method is it sort of gives you cognitive control. The problem with having 6 faces there at the same time is that you have a completely uncontrolled experience. That is, the person is trying to make a decision in which there's many different variables in front of them at the same time. You don't know what they're attending to at any point in time, what features of any face is figuring into their decision. And if you narrow it down to 2, then you know they're simply comparing those 2 faces. I think if you add more faces, it would just, I'm not sure. I imagine that there's a way that you could extract the perceptual scaling from those data, but I think it would just confound the whole thing. There is another thing that you could do, which we didn't do, which I think would be really valuable, and that is give people a scale. So rather than, there's just a binary choice in our case, which one looks more like what you remember. But if you had a scale, say a 7-point scale, then you get better resolution. And I think you could get more information from that than the method we use. But I honestly don't think, I mean, I haven't really thought about it, to be honest, but I don't think that having more than 2 faces at the same time would be beneficial in any way.
Carolyn, you look like you have something to say about this.
Yeah, I was just going to add in some information that we've been getting in our lab using something called a ranking task, which is not that different really. So it still relies on this idea of Thurstonian uncertainty, which is kind of what that paired comparison task is looking at. But the idea is that people rank each of the lineup members. And what we've been doing is modeling that using something called the Bloch-Marshak inequalities. So these are mathematical inequalities that kind of test whether or not people are using a monotonicity to scale their certainty and their perceptual discrimination. So if we test that using those inequalities, what we find is that there's information in the first few ranks. So people can express their memory strength and scale their memory strength effectively down to about rank 2 to 3. But after that, you don't get a lot more information from them. So that kind of concurs with what Tom's saying about the importance of, I guess, designing a task that respects how much information people are able to order in their memory in terms of memory strength, and then, you know, not placing too much demand on the witness and doing things in the task that might actually, you know, limit their ability to actually express that memory strength effectively and give you the maximum information that you can get from them.
John, can I respond to that?
Sure.
Yeah, so I completely agree with what you've said. My only hesitation about the ranking task, I mean, it is a way to get more information, but the risk is that it's a criterion-dependent judgment. And so once you start, I mean, this is, again, the problem with the regular lineup, is there's some criterion in the witness's head that you don't have access to, that they're using to make a decision. And the same is true when they rank them. You don't know what criterion they're using. By using a forced choice, we're eliminating, I mean, the subject does have some criterion in their head when they're doing a forced choice, but it simplifies the whole thing, because it's either this one or that one. That's all you have to do. And it's just a much cleaner task, which is the reason why Fechner developed the 2 alternative forced choice to begin with.
I should have clarified, Tom. We actually force them to rank, so there's no. It's a free. It's criterion free, which is why it matches so nicely with your results. With I think with the paired comparison task. Yeah.
Anna, you have your hand up.
Yeah, so I kind of have half comment, half question, going back to what Alice said about the amount of information that can be added or extracted from those interactive lineups. I just wonder if it's interacts with individual differences. So for example, we know that in the basic developmental prosopagnosia literature, there's research by Natalie Butcher, who I've actually seen in the audience, so hello, suggesting that movement actually helps face recognition. So I don't know very much about lineups, but in basic science, we know that if someone struggles with face recognition, those extra bits of information can help. So Alice, what do you think? Like, do you think that might interact with, that if like someone really struggles, actually that is some bits of those extra information might actually help rather than distract?
Yeah, so I mean, a long time ago, we wrote this review in TICS, like 2002, and there are really just 2 ways you can imagine motion helping face recognition. One is it gives you structure for motion information in pure visual terms, and that would mean that if that's the case, then the interactive lineup should be no better than the motion one. And other studies we've done that actually agree with it, more basic science. So I don't think there's a ton of data to suggest that structure for motion helps you build a 3D representation of the brain in the head, or of the face in the head. But that's another topic entirely. The only other way that motion could really help is if you get what we call dynamic identity signatures. If someone has a particular way that they move their face or smile that's characteristic, and that turns out there is good evidence to suggest that works really well when you know the person well and you've seen them enough to say this is characteristic, this is not characteristic. But how much it works with like a single encounter. I mean, to have that memory cue there when you're testing, it has to be exactly the same idiosyncratic stuff that you witnessed during the event, which makes it kind of lower probability that the bank robber is going to do the same thing in the lineup, look as nervous or look as twitchy with the, the eyes, or whatever. So, I think we have always, and there is one or two studies to suggest under certain circumstances that motion does help. But I think by and large, it's something that goes, it's on the positive, you can get more information, but it fights against the fact that when people move their faces non-rigidly, you're processing the social information.
Yeah.
And your brain is like, are they smiling? Are they going to hurt me? Are they coming? What is their intent? And that takes part of your brain. And the other part is like not working as hard to say, oh, they have a big nose or whatever else would help you with the lineup. So we discuss this a lot in the ancient ticks review. And so it's not updated, but it does lay out the basics.
But I suppose that would be one way of improving improving or expanding the interactive lineup procedure by adding not only rigid but non-rigid motion.
If you can match it to the circumstances of encounter, one would think.
Or hope that it matches by showing expression. But thanks.
Okay, contrary to my prediction, it looks like we could discuss basic science from now till eternity. So I want to move on, but Tom, do you have a quick point you want to make before we, or hold it till later?
I'll make a very quick point, which is I agree with Alice about I think she raises important issues about the value of motion. And I think the critical thing is attention. The visual sense is acquisitive. That is, I go out in the world and I move my visual system around in order to acquire information about the structure of my environment. And as long as I'm doing that I'm controlling it, I'm more likely to be attending and getting the information I need about three-dimensional structure. And simply watching somebody passively while I'm sitting still move around the world is, I think, as Alice points out, a different kind of situation.
Okay, thanks. And I know there's a question in the chat still we haven't gotten to, but let's press on for a little while and maybe get back to that. I invite Ryan Fitzgerald to comment on the question I have or anything else he wants to say. My question to him was, does he have any thoughts about the results obtained using interactive lineups and how they might interact with filler similarity in a fair lineup?
Sure, I'll resist the temptation to talk about all the other stuff I want to say because it is a really good question and I like the question. So I'll start by talking about what we know about how the fillers affect the identification outcomes. And I've done some research in my lab. Gary Wells did research on this 30 years ago. John, you and Melissa and some other people here did a massive study. And all this research shows that if you have a half-decent description of the perpetrator from the eyewitness, and you have fillers who contain all those features that are in that description, then you don't want to go too much more in terms of similarity matching when you're choosing the fillers beyond. So you get a pool of people who match that description. And the research that's been done shows that you get the best outcome if you choose people who are otherwise dissimilar to the suspect. So they have those features in the eyewitness description, but you don't want to go more than that. And that improves outcomes because it makes it easier for the eyewitness to find the perpetrator in the lineup because they can look for features that they haven't already described, and they're more likely to find them if there's variability in the lineup. And there's a but to that, and it has to do with the interactive lineup and how that might have a role here. The big but is that if you've got an innocent suspect who is very similar to the perpetrator, putting that person in a lineup with people who look nothing like that innocent suspect could increase their risk of mistaken identification. And the interactive lineup, if it is increasing the match between the witness's memory of the perpetrator and what they can see about that person in the lineup, maybe we don't need to go so low on the similarity to help the witnesses find the perpetrator. Maybe we could go a bit higher in similarity to increase protection of the innocent suspect, and we don't have to worry about it preventing correct identification of the perpetrator, because we're increasing the match that they have to that person using that interactive lineup. And the big question is, would the innocent suspect look like the perpetrator? And maybe not. So it really depends on why they're under investigation. So let's say that an eyewitness saw a license plate of the person drive away, and they got it a little bit wrong, and they report just a slightly wrong license plate. Then what you would expect is that the innocent suspect's license plate would be very similar to the perpetrator's license plate. But would they be similar in appearance? I can't think of any reason why they would, based on that reason of suspicion. But there are other reasons of suspicion that do increase the likelihood that an innocent suspect would resemble the perpetrator. So in the paper that you published, John, with Gary Wells in 2017, you talked about this guy, Michael McAllister. And you noted that he had a striking resemblance to the perpetrator, and you noted that it wasn't a coincidence. He became a perpetrator because he matched a composite sketch of the perpetrator. So if you have an innocent suspect who's in the lineup because of their appearance, if there's something about their appearance that made people suspect that that might be the perpetrator, then you might want to increase the similarity of those fillers to the suspect. And the interactive lineup might help witnesses identify the perpetrator if they're in the lineup, or it might, having that higher similarity might protect people like Michael McAllister.
Yeah, those are all really good points you just raised. And I just want to say two quick things before I move on to Carolyn. One, it's interesting that we're doing sort of one point is that the idea of using dissimilar fillers, police hate the sound of that. So I've discovered that so far. And one point that we're going to emphasize going forward, that these people at Stanford, I forget the line of research that they're doing, but a point to be made is that it's not just the fillers don't just match the description; they have to do that. But also important that they be chosen because they would have been described that way. So you can match the description, but have some tattoo, and like the witness would have described that tattoo. So yeah, although they match the description, and that's what people do in practice, like the police take them out. But when we're talking about dissimilar fillers, I've found that helps to get the point across. If you emphasize to people, they would have been dissimilar, yes, but they would have been described in just the way the witness described that guy, and that works better. But and the other thing I'll just quickly add about selecting innocent suspects who match the perpetrator because you got them from, say, a composite sketch. We're doing a deep dive into the wrongful conviction database, the Michigan one, looking for, in search of high confidence misidentifications on the initial test. We want to find every case in the world where that happened. And what we found so far is A, it doesn't happen very much, and B, when it does happen, it's surprising how often they've got the suspect from a composite sketch, just as you're saying. It's kind of amazing, but yeah, all very interesting. I can't believe how fast time is going by. So I'm gonna skip ahead here now. Thanks for those thoughts, Ryan and Carolyn. What I have here for you is interactive lineups enhance discriminability overall, but apparently without affecting the magnitude of the cross-race effect. At least one of the talks said that. Do you suppose the same might be true of other estimator variables? And might your new ranking procedure bear on any of this, or anything else you want to say?
Thanks, John. First of all, I'd like to say that so far I've got about 20 million ideas for extra experiments. So thanks, everyone. So what we really want to know is where this discriminability comes from. So I'm always thinking about measurement. And signal detection theory is a measurement model, but it also is an interesting model, way of looking at data, because it straddles this boundary between process models and measurement models. So when we're applying signal detection models to identification data, we're asking questions about not just what produces better discriminability, because obviously that's absolutely key in this context. We're also asking questions about the constraints that a lineup task places on a witness's memory, or their ability to translate their memory strength into a decision or some kind of response that can be used in the criminal justice system. So when we come and we look at the other race effect, probably the most comprehensive study on this has been the study by Koloff et al. So Heather, Melissa and Travis and a whole bunch of people collected some really great data comparing the interactive lineup across a few different kinds of conditions. And from that, they found that this interactive lineup approach produces better discriminability. But importantly, they compared this interactive lineup across two critical conditions and crossed it with other race versus own race identifications. They looked at all of the faces moving at once, and then they looked at control over whether or not people could actually explore or actively look at the faces individually, move them around individually. So when I read that paper, one thing that stood out to me was, first of all, that it appears to give the impression that the other race effect is all about encoding, so differences in encoding, and that this interactive lineup allows witnesses somehow to use the movement of the faces and the comparison across features to better express their memory strength. So that's a really good reason to say, yeah, let's use it. But the big question is, how does that work? So how do we work out the how? How do we answer that basic scientific question of the process by which witnesses are actually gathering that information as they interactively look at these faces and then translate that into a decision? So the closest thing that we have to a process model in this area is the diagnostic feature account that John and Laura came up with. And an instantiation of that, so a mathematical or computational model of that, is the ensemble model. So I think we need to take the ensemble model and we need to be applying it to the data from the interactive lineup. And we need to see how that decision rule within the ensemble model, which is an instantiation of diagnostic feature detection, actually maps onto the decision process that people are using. So if we can use that as a starting point for building a measurement model of this particular task, we might be able to answer the question of how people are actually benefiting from the movement of faces and interaction with the lineup as well. Some other things about estimated variables. So I think definitely the weapon focus effect is an important estimator variable that we want to look at to determine whether or not this type of interactive lineup also helps with that problem. But I'd actually like to see another estimator variable looked at, retention interval. So I think retention interval might actually tell us a lot more about the effects of encoding and the translation of encoding and attention to faces as people are using this interactive lineup. So I reckon the next experiment to do is a retention interval experiment. So looking at that as an estimated variable, comparing an interactive versus a non-interactive lineup for a retention interval, and then using the ensemble model to actually extract discriminability on the basis of fitting that model. And that could tell us a heck of a lot, I think, about the mechanisms by which people are actually solving the lineup task. So yeah, if anyone wants to run that experiment, go right ahead.
We did. Travis, probably putting on the spot here, but with a little bit of warning, we did try different retention intervals. It was a difficult study to run. COVID happened and Travis also went to Duke. And so we kind of gave up on it for a while, but we were really fascinated at looking at the shape of the ROC to tell us a bit about whether familiarity-based responding increased over time and whether we saw it increase more slowly, so to speak, in an interactive procedure compared to our control condition, which I think was static frontal pose lineups, if I'm not mistaken, Travis?
Yeah, it was static versus just interactive list learning experiment. We basically did the same experiment that John did with some patients in Arizona, I believe. I forget the year, but we basically did that experiment and we added on a condition where it's the interactive lineup. So we varied retention interval. Yeah, we still have those data, so we could share those data with you.
Have you fit the ensemble model to the data?
I think I have, but it was a long time ago, or
we were mostly excited about the shape of the ROC.
Yeah,
so I don't know if we ever got
John
any
made the
further
point
than that.
The shape of the ROC can
more data.
Oh, sorry. Oh, John made the point that like the shape of the ROC can kind of inform you about whether recollection's contributing or familiarity is contributing. If it's an asymmetrical ROC, then perhaps that's a sign that recollection's contributing. But if it's a symmetrical ROC, then perhaps there's no recollection and people are just making familiarity-based responses. So we're kind of interested in like, is interaction boosting recollection over time, or how is it that interactions leading to better performance? That was kind of our main thought, but
yeah, I think there's much more to be done in that. And I think one of the things as well that's really important to think about is reduction of entropy. So John and Tom before were talking about reducing, trying to increase this memory signal. But one way we can think about the lineup task is reduction in entropy. And context reinstatement is really critical as well. Like none of our models at the moment really have a parameter that maps onto reinstating context. And it may well be that over longer retention intervals, context becomes absolutely critical. And maybe it's the movement of faces that are actually allowing more contextual cues to be used to support memory. So, I mean, that's a possibility that I think could be really interesting to explore. But what we need is some work on that ensemble model to try to understand have we captured context within that decision rule, or do we need more parameters in that model to actually understand?
I gotcha.
Yeah.
I will say I can't remember all the results exactly, but if this is informative, the ROC did get more symmetrical over time. Obviously, it reduced as retention interval increased, but it did get more symmetrical in line with sort of what John's finding before.
Let me jump in here, Travis and Tia. I know there's a question to be answered, but I'm afraid we're going to run out of time. And Heather, do we have a hard end at 20 minutes from now, or can we continue on? Because we haven't gotten to the applied questions yet, and I know that I want to hear from those people. So maybe we should get a few quick points from Anna and David, and then let our applied folks weigh in, because that's going to be interesting. What do you think, Heather?
I'm happy to keep going. Lauren, is there any reason not to, if you made me host?
No, I think it should be fine. Yeah.
Great, thank you. Okay,
I'm just getting stressed looking at the clock, and this discussion is so fascinating. I find myself reluctant to jump in, but then we're timing out here. So let's press on and get a few thoughts from Anna and David, and then let's get to our applied folks who will have something interesting to say, no doubt. So next on my list is Anna. And the question was, if you wish to answer this one, performance on 2D lineup tasks can vary widely across subjects. What can we learn from analyses of those inter-individual differences to improve lineup procedures and increase ID accuracy?
Thanks. So my main thoughts are that we need to learn a lot more about the individual differences in lineup procedures, because the evidence actually on individual differences are in. So we can think about it in two ways. So first of all, there might be individual differences in the basic face perception or face memory, and there might be the individual differences in bias. So people's proclivity to choose or not choose. And I think broadly with face perception literature, we quite often study those individual differences and as kind of single factors trying to control for others. But I like to think of face perception and face recognition as something that is much more complex than that. So, when we interact in a 3D world, it's not just face perception or face recognition, the size of the town that we grew in, or our personality. A lot of those factors interact. And it might be that we need to start really looking at modeling all those individual differences in tandem and looking at them at face recognition more as a system rather than sum of individual parts. So I think how could we, well, one of my thoughts on how to improve the lineup procedure would be, and I absolutely agree with what Carolyn said about the context reinstatement. So, how that must be so important, and how people view the subject, although that's not so much to do with individual differences. But I think, looking at a system level and studying individual differences, it would be a big scale study to run, but nonetheless, I think we could learn so much about what factors influence lineup performance and how we can optimize those procedures for people who struggle with them, and what can we learn, and the flip side, what can we learn from people, so-called super recognizers? Are they better on lineups, and what makes them better? So here's my 2 cents. Over to you, David, I guess.
Okay, thank you. And yeah, you're talking about modeling. I saw Carolyn nodding. It was music to her ears, I think. Okay, and David, I had a question for you, but somebody asked an even more interesting one, so I'll put it to you. One of the talks tested the hypothesis that super recognizers or other high-performing groups would benefit more from interactive lineup displays. Why might these groups benefit more? Would you like to try your hand at that one, or something else?
Thank you, John. Yeah, I'll try my hand at that one. But first of all, I'll answer the first question that was going to be asked, which was about diagnostic features. I think the question was, is this interactive lineup procedure effective because it enables the witnesses to see diagnostic features? Now, I think that must be a major reason, of course. I mean, if you see a feature that is particularly signaling of a person's identity while you're looking at that interactive procedure, it's very likely to cause increase in memory strength, and therefore a better recognition decision. But I think the important thing is it doesn't that information would be available in the video, right? So clearly here there is something active that is important. It's not that it only enables the participant to see the diagnostic features, it enables them to find them. And I think there's a paper by Melissa Koloff, which I read in preparation, which used the word exploration. And I agree that this is an interesting thing here. What appears to be interesting is that it's an active process of exploration and discovery of the diagnostic features. Because I think this is often seen as a passive process. But what this interactive procedure really adds for me is the ability to actively search. And I think that's more worthy of more study, that process in itself. In recent eye tracking work, and this sort of segues into the super recognizer stuff, we've done a lot of eye tracking recently work with super recognizers, limiting the visual information that they see on any one fixation. And what the main finding is for us, or one of the main findings, is that they appear to explore faces much more. They take more samples of information from a face. And so I think my sort of working hypothesis at the moment is super recognizers. These are people, by the way, that are extremely adept at face recognition. They're at the upper end of the individual difference spectrum. I think they're sort of fascinated by faces, and we might expect that if they give them the opportunity to explore these interactive lineups more, that they will take better advantage of that. Now, of course, in the memory context, and there is a paper on super recognizers, which was also part of the preparatory reading by Harriet Smith. But that paper looked at matching. Now, of course, super recognizers, their name suggests that recognition is the main locus of their expertise. And indeed, you might expect that you would see stronger benefits or, for super recognizers being given this interactive lineup than typical viewers, just by product of the fact that they are likely to have better memory representations in their head as well. And so when they're given the opportunity to explore these things, they have more to match it against, I guess. So I hope that answered both of your questions, John.
No, that was great. That makes a lot of sense. Thank you. That was great. So I think we should move on to applied questions. Obviously, I got it completely backwards. We bogged down on the basic science because it was so interesting. I thought we would do that if we started with applied. And so let's move on to the applied discussion. And really, in a way, the question to three of you, to Karen, Bill Wells, and Nick Gibbin, is almost the same question. Like Tom Albright said early on, like, it makes total sense to do this, why not do it? And you people are the perfect people to address that question. So Karen, why don't we start with you and ask about that? And but Bill Wells, Nick Gibbin, and anyone else, feel free to join in on that discussion. Karen, what do you think?
Yeah, so I don't think there's anything in policy or law in the US that would prohibit implementing this procedure. The problem is, as Tom mentioned, part one, is that the source of those photographs in the US tends to be primarily from driver's license photos. And the implication for that is that everybody who gets a driver's license photo taken has to get 3 photos taken, right? And that's a big cost probably to the state agencies that issue those licenses. So that's like problem one. Problem two is getting the word out to agencies about policies. And the reason I mention that being so important is that there are a number of policy-based organizations in the United States anyhow, who either advocate for certain policies or actually develop certain policies. So in working on a current, we're just about complete with collecting data on a nationwide stratified random sample of agencies, both police, local police and sheriff's departments in counties. We've asked them to not only answer the questions, but also upload policies. I didn't expect to get that many, but as Ryan had mentioned earlier, he'd looked at many of those. We've gotten so far about 90 policies, and I've just taken a cursory look at them. And one of the things that I can say is that first and foremost, many of the agencies have not even adopted practices that have been highly recommended almost universally over the last 5 to 8 years. Secondly, we asked for the source of many of the policies on both show-ups and photo arrays. And in many of the cases, and I venture to guess it might be about a third, they're using a policy that was developed by a profit-making organization that develops policies for organizations, and they just minimally adapt it to their agencies. And I can tell you that those policies don't reflect what we know in the science in the past 5 to 10 years. So this is the biggest problem, is not just the science behind it, but how do you practically get across that this is the current science and that this could be beneficial, and then get that to be adopted in policies in places where they're basically buying policies. They're not really developing policies. So that's it for me.
See, that's why I became a professor. The real world is just way too complicated to deal with. Okay. So Wayne, I'm going to come back to you in a second, since the same question basically is for Bill Wells and then Nick Gibbin. Bill, what do you think about, like, even doing a study on this in a police department? Would they resist it mightily? Would they be open to it? What do you think?
Yeah, thanks, John. The fascinating discussion, first of all. I mean, this is fantastic. If I could, I'd like to respond to the last comment that Karen made about updating policies and practices in law enforcement agencies in the U.S. And you know, one of the things that my state, where I live right now, Texas, did in 2011 is required that agencies do two things. One, adopt a policy. So that's step one, is getting them to have a policy that establishes practices for investigators. But then two, they directed my organization at my university to write a model policy. And we're funded by the state, so you know we don't charge money for that policy. So then what we were required to do was write a model policy, so any organization in the state could adopt it, and then we rolled out training that went along with that policy. So to answer your question, Karen, that's one model. And the Texas model policy was mandated to be created back in 2011. So it's been 10 years now. So Texas would make a great case study to look at policy development in the state. But and John, you know, I made a few notes on some of the things that I would see as issues related to doing a field study on this. So first of all, my first reaction is it would be very mixed. The reactions would be mixed, but I think that's a good thing. 20 years ago, to partner up with a law enforcement agency to do a field experiment would be pretty darn challenging, and it's different today. Police agencies are led by innovative individuals who want to experiment. They're informed by data. It's much more common and expected and normal for innovative police agencies to get involved in these kinds of experiments and studies. So that's very promising. It's very hopeful, at least in the United States, to do these kinds of studies. So a couple of the barriers that I would see that we would need to think about as a community to overcome with police agencies is, number one, tech integration. The ability to use non-paper products is challenging. So when we did our Houston field study 10 years ago, a neighboring university with a much larger endowment than my own set their computer science department to work with the Houston Police Department for 1.5 years to try to use iPads and laptops to show the photo arrays, either simultaneously or sequentially, to witnesses and victims in robbery cases. So that university tried for 1.5 years to integrate with the HPD data systems and essentially got nowhere. It was essentially failed from the beginning, which is really too bad. So tech is a big inhibitor to doing this in the United States. Next, if you can overcome that barrier, then actual use in the field also becomes challenging. And this was very eye-opening to myself and to the students I worked with on our study. Eyewitness identification procedures by police departments are done in all kinds of unusual locations: on the hood of a police car, in a crowded parking lot, in the broom closet of a school, with the witness to a crime, in a fast food restaurant, in someone's apartment, where people are coming and going. So very challenging to control that setting in which police collect that eyewitness evidence from witnesses is also a pretty big challenge. Next, related to the science of all of this is randomization. And I don't have to explain all of that to y'all. The problem of randomizing cases to be implemented in a certain way by an investigator in the field, extremely challenging. So we do the best that we can. We had to throw out some cases that violated our protocols. We had to use a sort of quasi randomized procedure that I think is still pretty darn good for what we were able to accomplish, but randomizing is very challenging. I'll just say two more things so I don't ramble on too long. Concern from district attorneys. So we got a lot of pushback early on from investigators and from the DA's office that this is going to bias their cases. They're going to be subjected to a lot of challenges from defense counsel, and they're going to lose cases up front. So one of my tactics and one of my approaches was I went over to the Austin Police Department, which is where one of the sites that Gary Wells and Karen worked on the field study over there. And I met with several investigators over there, and they didn't have a single case in which that became an issue. So I was able to take that back to the HPD investigator, say, look, I went over, talked to the Austin folks, not a single case, not one was actually compromised because of this. So that is a concern that will come up about changing these procedures. But I think there's a way of effectively overcoming that challenge. Last thing, and this kind of takes the discussion in a little bit of a different direction, but like the research I'm interested in doing and moving forward is how this evidence impacts case progression. How does that impact the next set of evidence that investigators collect? How does that impact their re-examination of evidence they collected early on in their case? And then moving forward, how does it, if at all, impact prosecutorial decision-making up front, whether to accept charges, what charges to accept, and then how it proceeds from there? So those are sort of the kinds of system-based questions that I'm really interested in asking. And one of the things I haven't gotten around to doing yet, I hope you'll sympathize with me. I'm serving as department chair, so I don't have much time to do this, but to go back and look at our original HPD cases from back in 2012, 11, and 12, 13, and see how they progressed through the court and disposition outcomes in those particular cases. So anyways, thanks for the time. I really appreciate it.
Okay, thank you. Wow, I learn a lot per second when I hear people like Karen and Bill talk. There's just so much to what the real world is like. Okay, we're going to go beyond the time limit a bit. Heather, I hope that's okay, because this is too fascinating to cut off now. And Mick, I would like to hear from you about all this. I'm wondering if, you know, the obstacles in the US are much greater than the obstacles in the UK, where things are more centralized. But what are your thoughts about that?
Yeah, thanks, John. Yeah, basically, the main obstacle here is for anybody to trial the system or to roll the system out is the database. There simply isn't one at the moment for interactive parades. In the UK, we've been doing video identification parades since 1997. And in that time, we've built a massive database, hundreds of thousands of records. Currently, for the interactive, we don't have a starting point. It's fairly easy to take the database that we use in the UK and make that interactive. That's not a problem, but there's legislation issues behind that. So you can't, it's not really practical. I suppose, well, you'd have to basically do a capture day. In the UK, we've been through various processes. Initially, different police forces will go out and do capture days. They'd go out to universities or wherever, sit people down, get them together, and capture them and give them 10. I think they used to give them £10 or yeah, £10 a throw, basically. And they got about 30,000 together, and they realised that 30,000 was a reasonable number, but there was a lot of holes still. There were certain people, certain face types that just didn't fit. So eventually I think at some point, if I'm not mistaken, we actually changed the legislation in the UK and allowed for suspects who come through custody to be captured and used as volunteers in the database. And that's effectively what we're doing in the UK now. So it builds itself. So what we've been pushing is these booth type systems where people sit down and everybody that comes through custody in certain UK forces, not everybody's adopted it yet, has their video captured. And that's building the database massively. And it's really bringing us, because your other problems is refresh. If we look at the original clips from '97, they're useless today because the quality of the video footage is much better nowadays, and fashions change. So your database has constantly got to refresh. That's basically the main obstacle moving forward that I see with this.
I see. More obstacles than I would have thought there, but maybe a lot less than they're going to face in the US. Okay, thank you. Very interesting. It's amazing. Like, I'll just repeat what I said before. When you talk to people who are in the real world, it just seems so obvious that people should do something, but getting from what the science says you should do to actually getting it done is super hard.
Perhaps Wayne from Viper would like to comment, given his experiences with Viper and supplying the 22 police forces with some of the issues of implementation, or anything else really, Wayne, that you would like to bring up.
Thanks, Heather. John Yes, I did plan to answer the question that was in the bundle, and I will do so just very briefly, and then I'll move on to the interactive work, Heather, if that's okay. So the question, John, just to basic it, was about the role of confidence in identification parades, and what I would say in terms of UK policing, we have asked this question to probably half of UK's most senior staff who were involved in identification parades, and the question was asked by an academic at an event hosted by an academic on our premises, and the academics and the police fought it out for about 15 minutes, and it was quite an interesting conversation. Ryan Fitzgerald is on the call today. He was part of the refereeing team on the day, as was Melissa Koloff. So that they may well have another side to describe, but I thought at the time policing wasn't really rushing to include confidence measurements in the documentation produced at the point of a parade. There was no one jumping up and down in the audience either way from policing, and there was a sense of nervousness about obvious things like what measurements to use and language barriers and understanding by the witness of what they were being asked to do. But ultimately, at the end of that discussion, I sort of matured a little bit and thought, I think it will probably happen. And there were a couple of forces who were more interested in introducing it than others. So it's a piece of ongoing work. And I think as academics, you need to push us harder. We work better when you're pushing us hard.
Oh, don't invite me to do that, because you might get your wish.
Well, no,
come back to haunt you, Wayne.
moving on to what I'd like to say is that I think policing has got a really difficult task absorbing all the things that the academic community say. And when people, in this broad group speak so eloquently about things that we do in an applied way, but describe it in a theoretical way, it starts to hit home on areas where we need to talk more and more frequently and more deeply. There are a number of topics that have been discussed today that are genuine theoretical arguments that need to be exposed to people inside policing, and that will open the door to research. Here at Viper, we've made a conscious decision to get actively involved with the academic community, and it's a very slow drip so far, but all of the activities that we've done so far have been really, really valuable. And we've got Tia on the call, and we're going to be working with her for 3 or 4 years on something regarding similarity. And I don't think the people who attend the Viper meetings would have believed how much value we get from having people like Melissa and Heather and others on calls where we talk about the absolute obvious parts of policing and the very detailed parts of policing that are involved in the day-to-day use of identification parades. And just listening to William and Karen briefly before me, they've got very similar mentality to myself about the challenges are all ready to be addressed, and there's potentially a long queue inside policing to help that happen. It's just the approach has got to be right and the confidence has got to be high. Speaking about the change in the database, which I think Mick raised, we, as recently as 2016, replaced our volunteer database. Our volunteer database was, as Mick described, had been created over a long period of time, as far back as 1995, and it had been replenished and refreshed over time in the way Mick explained. But in 2015, we decided to only use volunteers who have agreed to be recorded for the purpose of video identification. We do pay them a fee. Quite a lot of those fees go to charity. They decide to put it to the benefit of a local charity. So we restarted our collection up to the quality, up to the contemporary nature of the images, changed a few of the rules and how things are recorded. We use a booth, but it is a big difference in how Viper handles volunteers or foils or whichever we want to describe them. So the collections are quite different for that very reason. But introducing a new collection of images wasn't easy. We did get some help from government. We had to go as far as putting a bid in for some assistance, and were successful. And the grounds for being successful are all the good things that are being discussed here by people trying to make things a little bit better. So I would reiterate the point that you need to tell us what you think is really important, and we will then convert it into a conversation, a language that we can understand better inside policing. And I think you'd be surprised what sort of results you'll get. And you're right, Heather, I may be really worried about how many calls I get, but that'll be a lot more calls than we used to get. And even in the last 2 years, we have seen great things come from a conversation. And a lot of this is down to Ryan Fitzgerald, who's also spoken earlier today. I jousted with Ryan for a couple of years during the research that he conducted when he was in Portsmouth. We gave him a booth to help him with the research. We're just about to do that with Birmingham as well. And he left me with something sort of ringing in my ears, which was, well, it's all well and good, Wayne. You tell me how things happen in practice, but you need to open the doors to us academics to try and employ research inside policing, or you won't get very far at all. And I still remember that conversation, not in that real context, but just how important the potential changes are that policing is often too closed away to even look at.
All right, thank you very much. That was very informative, appreciate it. And something you just said interacts with something, the last question I want to ask to Tom Albright in a minute, if he's still with us. See, we're running late, but Tia, you have hand up.
Yeah, we do have a question in the chat just asking about if 30,000 faces aren't enough to populate a face space, how many faces are ideally enough?
Yeah, I can come in on that one. Yeah, we currently run 60,000 for each system that's out there, but separately to that, back at the head office, we also have an additional pool of about 100,000, which we can draw on. If any weird, sort of strange requests come through, we have to fall back on that. And if we fail there, then we've got to go get some more people. We move to still parades, or there's other technology lying around. It's face morphing now, where you can start to build faces digitally. Something called NVIDIA StyleGAN is a good example of that. So there are ways and means, but yeah, 60,000 is about right, and will produce for us 99.5% of every parade.
And Wayne, you have something to add to that?
Yeah, the number Mick mentions is about right. We have just less than 60,000, and we produce parades 24/7. And at the moment, due to restrictions on COVID, we aren't actively increasing the volunteers on our database. And we have a very short list of wants for that collection. Some of those images are highly specific with very unique features, and for the most part inside UK codes of practice, we're allowed to create volunteers using we replicate features onto volunteers, and that's a highly successful way of coping with appearances for very specific people. And that's a practice that's been around in policing for over 10 years here in the UK.
Okay, thank you. So one thing Wayne said earlier, you need to push us more, scientists need to do that. And one thing I feel like I've learned that I never knew before, as a result of the NRC 2014 report, is that the power of that push is greatly magnified when one can assert a consensus opinion on something, especially from a body like the National Academy of Sciences, rather than just individual researchers like me coming and trying to badger you to do it my way, and a different scientist is going to disagree with me. And I just, Tom, if you're still here, I just wondered if you've been through that process of acquiring that kind of consensus. And I've seen, although Karen said a lot of police departments, they just hire, I don't know, policy companies that don't pay attention to the science or something like that. But a lot of others I know paid really close attention to that NRC report. And I just wondered what your thoughts were about that, and that, because I would imagine that, pushing to you, it's a complete no-brainer, and I agree that interactive lineups should be used, but getting from here to there, I can also imagine would require something like what you did on that committee. And I'm just wondering what your thoughts are about that.
Well, thanks, John. It's a great question. Before I go there, I just want to make one comment that's relevant to the discussion that was just going on. And that has to do with, somebody had mentioned this actually, face morphing. So there are a number of these programs, probably most of you are familiar with them for face morphing, and they're really powerful and they're kind of amazing, a little freaky too. But you can create all sorts of faces that are of non-existent people that look like real people. We've been playing around with this in the laboratory for unrelated reasons. And so you don't need to go out and collect these databases from 30,000 people in the wild. You can just make them. And you can make the diversity of them. I mean, you can narrow them. We did this for a study we're working on right now, where we wanted, it's kind of bland, but white men and with no facial hair. And so we just created a gazillion faces of white men with no facial hair that are all different somehow. And you can make 3D versions of them because they're all computer generated faces. And I think this is the solution to the database problem. Anyway, I just wanted to throw that out. But to come back to John's question, so yes, I served on this committee, the Eyewitness Committee for the National Academy, and I served on the parent committee for 6 years, the committee that commissions these kinds of consensus studies. This is called the National Academy's Committee on Science, Technology, and Law. And there are lots of interesting topics that committee overseas. And I could see easily that, because I should preface this by saying that the National Academy has a deep investment in this kind of, and this topic and this kind of research. The 2009 report on forensic science was one of the most widely cited reports that the National Academy has ever produced. And the 2014 one on eyewitness identification is pretty high up there too. And they feel, this committee on science, technology, and law feels that this is something that the Academy should stay on top of as it evolves in the future. A consensus study that's focused on this issue of interactive lineups might be a topic that would be considered too narrow, but I could imagine a revisitation of the general issue of eyewitness identification science in the future. Just going back to, probably the easiest thing to do would be to organize a workshop. The same committee, Science, Technology, and Law Committee, puts together workshops, a couple of which I participated in earlier this year, and they draw a huge audience. There is a workshop proceedings, which is not a document that's as detailed as the consensus report that we did for the eyewitness thing, but it's nonetheless a piece of information that's tangible, and there are videos from the workshop and so on. So I could see that that's a possibility, but sitting down and having a consensus committee that is solely looking at immersive lineups, as important as I think this is probably not something that the Academy would go for. One thing that affects all this, of course, is it affects everything, is money. These studies, these consensus studies, have to be funded somehow. The Arnold Foundation funded the consensus report on eyewitness identification, but it's very hard generally to find people who are willing to put money up for these kinds of things. Sometimes it comes from a congressional mandate. The Congress says they want to report on something or other, and then the US government funds it. But the Academy doesn't have deep pockets to just fund these things on its own. And it's a surprising amount of money to put together a consensus report. But I interact with these people all the time, and I keep pushing this issue of forensic science and eyewitness identification, and it won't be forgotten by the Academy.
Okay, thanks, Tom. That was definitely the voice of experience, relevant experience there. I see Karen has her hand up. I'm guessing she's going to rain on your parade of using fake faces. I don't know, Karen.
Well, no, well, yeah, maybe. But so Tom is talking primarily about funding for research, but the practical issue is with something like 14,000 or more law enforcement agencies in the United States, is who develops that bank of fake photos, if not the states, who probably will argue that they can't afford to do it. And where does the money come from to develop that large morphed sort of database, right? And so that again is one of the really practical challenges that, of course, research is always underfunded. And there are other organizations, as you mentioned, Arnold, and beyond the national academies, but also, you know, the Justice Department in the US and many others. But even then, to get them to put up this much money, especially in the US in light of a new $1.2 trillion legislation that went through yesterday, money's just not going to be there for this kind of thing, you know, unless there's some really strong benefit to be gained from their perspective. From our perspective, we see the benefits, but maybe many of the states wouldn't.
Okay, thanks. Alice, you have something to add, I think.
Yeah, and you know, this might speak a little bit out of ignorance, but the synthetic faces, and we've been looking a lot at this and using GANs generators and so on. My understanding, and if you have more data on this, I think it would be great to put something together. I don't know that the three-dimensional part of this has been verified to be exactly what would happen, because generally you don't have the three-dimensional parameters of the head surface, so simulating illumination, simulating pose and so on, in a way that you can be absolutely sure that if it were me and I turned my head and I lit it this way, it will look correct. But if there are data out there on that, I think that's fabulous, but I have not yet. I think there's more research to be done before we trust that this is going to be a good simulation. And if I'm wrong, tell me now. I would love to hear that, actually.
Okay, well, thank you. My fear when I started this today was that we were going to run out of stuff to talk about in 20 minutes and I was going to have to figure out a way to fill up the time, but actually we could go on for another 2 hours. It seems like this discussion was so fascinating, covered such a wide range of territory. It was all amazing, but I guess we should finally draw it to a close, sadly. And I want to thank all the panelists for participating in this. You guys were amazing, actually. I could talk to you for hours more. And thanks to Heather and everybody who helped put this event on. And also thanks to those of you out there who joined us for this event. It was an amazing event. I enjoyed it a lot. I hope you all did too. Tom, you have one more thing to say, it looks like, before we...
I was going to respond to what Karen and Alice said, but I think you're right. I'm just going to beat a dead horse and maybe not. We could have another discussion some other time.
Okay, that sounds good. Okay, then, I guess we'll draw to a close officially, and thank you all again for participating. It was amazing.
Thanks, John. Thanks, Heather.
Great to see everyone. It's wonderful.
Yeah, nice to see everyone. Bye-bye, Heather. See you.
Bye.